We're not quite done yet. We do want to simplify. So let's group our cosines together and our sines together, giving us 4t cosine t plus 2 sine t minus t squared sine t, which is 4t cosine t. We can factor out the sine t, giving us 2 minus t squared sine t. Okay, for part C, we're looking at f of x equals 2x squared cotangent x. Again, I see that I have multiplication going on here, so we'll use the product rule. I break this up to two factors, take the derivative of both sides. And then use my product rule to find the f prime of x is 4x cotangent x plus a negative, so I'll change this to minus 2x squared cosecant squared x. And then, if you want to, you can realize that cotangent is cosine x over sine x, and cosecant is actually sine, or 1 over sine. So we can factor out a 2x over sine x, which leaves behind 2 cosine x minus x over sine of x. Both are possible valid solutions for f prime of x. Let's move on to problem D. In problem D, we have f of x equals x plus tangent x all over sine x plus 1. In this one, we have division happening, so we're going to use the quotient rule. I still want to pull apart my problem. I'll pull this into the numerator and the denominator and find the derivative of both. The product rule tells me that f prime of x will equal u prime v minus uv prime all over v squared. So plugging in values, I find that I have 1 plus secant squared x times sine x plus 1 minus cosine x times x plus tangent x all over sine x plus 1 squared. The simplification for this problem is a little trickier, but first let's distribute. So we get sine x plus 1 plus sine x secant squared x plus secant squared x minus x cosine x minus cosine x tan x all over